Hello everyone and welcome to this video. This is a video explaining the size and the distance of our solar system. This is to help people kind of understand just how big things are in our solar system, which is the first stepping stone to understanding how big things are in our galaxy and in the universe as a whole. So, to begin, our solar system is so big and it's so vast, and there's a lot of space in our galaxy, in our solar system. Not as much as in our galaxy and not as much as in the universe, but it is a lot larger than sometimes we think. But it's really hard to comprehend the size of the universe and the galaxy and of our solar system alone, because it's hard to even comprehend the size of Earth, let alone other objects in our solar system, and we haven't even mentioned the distance in which they sit from each other. And so I hope with this video that you'll be able to gain a better understanding of how big our solar system actually is and the size of the objects within them. So in order to understand this, I wanted to break this down into some smaller pieces. So first, we are going to start with the size of the planets, and we're going to talk about how big things actually are. So this is a picture of that NASA has put together, and it's actual images of the planets, and they've compiled them together and um, scaled them down to what they would actually look like in comparison to each other. So this big white globe over here, this is the sun. That's a sunspot. And this is Mercury. And this little guy right here, this is Earth, and this is the moon. And sometimes we think the Earth is so big, but in reality, it's really small compared to other things in our solar system. And so this still, for me even, is really hard to comprehend, because I can't comprehend how small or how big the things are around me. And so I took the size of the planets and the sun, and I scaled it down to things that would make sense here on Earth. And so I made this beautiful um, representation of our solar system. So this big squishmallow represents the sun, and then all of these other objects down here are to scale what they would look like in real life. And we're going to talk about each one individually. But first, we're going to start with what I like to call the rocky midgets. And we're going to talk about each one individually and the scale that I used to scale them down to, so that you can kind of understand how big things are. So this is the sun. The sun is normally 1.4 times 10 to the 11th centimeters big, which is large. It's very big. And I took that and I scaled it down to make the sun only 61 centimeters in diameter, or about the size of a large squishmallow. Moving on, this is Mercury. If we scale it down to what we have from the sun to Mercury, Mercury is only 0.21 centimeters large, which is about the size of the back of an earring, which is what is in this image right here. It's an earring back. The planet Mercury, it's very small. Compared to the sun, Mercury is very tiny. And then we have Venus, which is about the size of the head of a nail, which is what this is. It's about 0.52 centimeters large in our scaled image. And then we have Earth. Earth and Venus are very similar in size, as you can see. Even in their scientific notation, they are not very far off from each other. Only a couple of numbers higher. Earth is slightly larger than Venus, but they're pretty close, which is why we call them we call them sister worlds. So in our scale model, Earth is only 0.55 centimeters large, which is again about the size of a nail head. And so it's the same nail, different colors, but they are about the same size. And then Mars is about the size of a small bead, which is 0.3 centimeters, which is not very big. And then we get to our beautiful asteroid belt. The largest object in the asteroid belt would only be 0.04 centimeters in our scaled model, which is basically a grain of sand, because the asteroid belt is filled with so many objects. The biggest one would be 0.04 centimeters, but in real life, The asteroid, one of the smallest measured asteroids in the asteroid belt is only 10 centimeters in diameter. So in our scale model, it would be extraordinarily small, smaller than we could even see probably with a microscope, because it's so, so tiny. So objects in the asteroid belt vary greatly from really big to really small. But they would be about, the biggest ones would be about 0.04 centimeters, which is about the size of a grain of sand. So not very big. This is just a chart kind of telling you a little bit of where we've been so far. We've gone through the sun all the way down to the asteroid belt at this point with their diameters. We've talked about these things right here, and these are the different objects that we have compared them to. We'll talk about distance a little bit later, like we were talking about in the beginning, but this is the scale and the chart that shows you the scale. Moving on, though, to the gassy behemoth planets. And we're going to start off with Jupiter. So in our scale model, from 61 centimeters to the Sun to Jupiter, Jupiter would only be about 6.23 centimeters, which is about the size of this little plush crochet creature, which is not very big. Jupiter is the biggest planet in our solar system, but it still is not very big in comparison to the Sun. Which is why he is this small. Moving on to Saturn. Saturn would only be about 5.23 centimeters in diameter, which is about the size of a large medication bottle lid. So it is smaller than Jupiter, but not by a whole lot. And then we have Uranus. Uranus would be about 2.2 centimeters in diameter in our scale model. And it is about the size of a nickel, as well as Neptune. Neptune and Uranus are also very similar in size. They don't vary greatly, and as such, in our scale model, it would only be about 2.1 centimeters in length, which is again about the size of a nickel. And then we reach the Kuiper Belt. So the Kuiper Belt has many, many objects in it, but I am going to use Pluto because everyone really likes Pluto. So I used Pluto. Would only be about 0.1 centimeters in length, which is about the length of the pointy part of a pushpin. So this metal part right here, that is how big the diameter of Pluto would be. So as you can tell, from Neptune down to Pluto, they get relatively small out in the Kuiper Belt. And again, here is another chart that shows you the different dimensions as well as the scaling factor and the different objects that we compared it to. But I wanted to go back to this image for a second. Now that we've talked about the different objects and their sizes, you can see that the sun versus the planets, the sun is significantly larger than a lot of the planets. Now that we have the size of objects, we can move on to distance. So in the scale that we have with our squishmallow being the sun, the distance on Earth that they would be, we're going to start from this road right here. This yellow dot represents the sun. This is Main Street in Ephraim, and this is Center Street, and then this is Main Street in Ephraim. And so we're going to go down Main Street in Ephraim to kind of talk about the distance that these things would be. So if this is our squishmallow right here, this yellow sun, this is ground zero. And then this next gray dot would be Mercury, and it's about 81 feet away, which is about probably a quarter of a block down the road a little bit. And then from the sun to Venus, it's about 154 feet. So we're pretty much doubling the distance from the sun to Venus versus the sun to Mercury. And then from the sun to the Earth, it's about 214 feet. So we're getting further and further out there. And if you were standing where the sun was and you tried to look at the Earth, and you tried to see that nail head, it would be very difficult because of how small it would be, right? And so moving on, we go to Mars, and Mars is about 307 feet away, and then to the asteroid belt, which has a mean of about 504 feet from the sun. It varies slightly because the asteroid belt is almost right next to Mars, and it extends a little bit further out away from that 504 feet as well. But the average distance, or like the middle of its distance, would be about 504 feet. Moving on to our gassy behemoth planets, Jupiter is about 1,113 feet. So we're moving pretty far away now at this point. As you can see, these are pretty close together, and they're relatively close to the sun. But as we move out further, we can't even see the sun right here because of how far back it is, and it is about double from where the asteroid belt is to where Jupiter is. And then we have Saturn, which is about 2,045 feet away from the sun, and out to Uranus, which is just insane at this point. We have 4,105 feet, just under a mile. And then, as you keep moving out, we reach Neptune, which is 6,422 feet, and then out to Pluto in our Kuiper Belt, which is 8,439 feet, or about a mile and a half, slightly more than that. So if we wanted to see all of these things right next to each other, we have the sun, and you can see that these rocky planets are relatively close, and this is laid out in our scale model, right? So if we were standing where the sun was and we tried to look out to the Kuiper Belt and see Pluto and see that metal bit of that pin, we would have a really hard time being able to see it that a mile and a half away from us. In fact, we would have a hard time seeing Neptune and Uranus and all of the other planets if we were standing where that was. So it's so big. The solar system is so spread out, and a lot of people get really worried about things like asteroids coming and hitting the Earth, or something catastrophic coming from space. But in reality, things are so spread apart in the solar system. In between all of the gas giants, there is very little debris. We have the moons that orbit, or nothing. It's just open space. In between these distances, there is nothing. So some of the things that I thought about while working on this video and while doing this was just how far apart the planets are, and how small Earth really is in comparison to the sun. There's so much space in between the different planets, and the planets themselves are so small compared to the sun, which I thought was very interesting. But I would love to hear your thoughts and impressions. You can leave a comment down below on this video. But as always, thank you for watching this video. Have a great day.